And now it's time for the latest exciting episode of Doz's Television Workshop.
Hello and welcome back to Doz's Television Workshop, where today it's part 2 of improving our AliExpress AM transmitter. Now, occasionally I'll put a video out to a select few friends and relatives just to get a bit of critique back on it, and I did that with part 1, and yeah, Nigel came back to me. And yeah, he's right. The Teensy is expensive. I wanted to do it because I fancied playing with that particular audio processing function. But it did get me to thinking that maybe if you don't want to spend a fortune on this project, yeah, maybe there's a cheaper way to do it. And we did it the old-fashioned way. So I lashed this thing up on a bit of breadboard last night. And yeah, let's step over to the computer and I'll talk you through it. Right, here's the schematic I conjured up. There's nothing new under the sun here. But I'll just take you through it. There's a little bit of power supply going on down here, so we can derive a sort of half rail supply for our op amps. Audio comes in here and feeds these two first op amps here, which forms a 4-pole Salon key filter. And that's our high pass filter. It's centered on around 100 Hertz. It's then passed into another 2 op amps. These are a low pass 4-pole Salon key filter. So that gives us our shape. This cuts off at about 5.5 kilohertz. So that output is then fed down here into a very old-fashioned kind of compressor. Now, this is called an optical compressor because there's optical components in it. This first amplifier here is just add some gain in to make sure we've got, 1, to make up for the loss in the filter, and 2, to make sure we've got adequate drive to our compressor stage, which is here. So here you'll see our output not only goes to the audio, but via this 100 ohm resistor here feeds a bridge rectifier. Now I've written here BAT54C and BAT54A, but those are just 2 Schottky diodes in a little package there. So that's forming a bridge rectifier, and the output from the bridge rectifier feeds a yellow LED, and the yellow LED is placed inside a light-proof container in close proximity to this GL5528 LDR. I did experiment with a few different LDRs, and that one seemed to work the best. And as you can see, the LDR is in the feedback loop to our amplifier. So when it's dark, i.e. the level is too low, so the LED is not lit, the resistance here is about a megohm. So we've got quite a lot of gain in there. So as soon as a bit of audio comes along, and we've got a lot of gain in there, obviously it's rectified here, lights up the yellow LED, which turns the gain down in this amplifier, thus compressing the audio. This idea is ancient. It's been around forever. Originally, back in the day, this might have even been an incandescent bulb, and the amplifier would have been a little more gutsy to drive an incandescent bulb. But that's how it works. So the louder the audio, the brighter the LED, the lower the gain. It is a little bit in your face. So yeah, let's go back over to the bench and have a listen to it.
Echoes lost in the amplifier's hum, voices tangle in electric dreams, wires twist and currents run as broken notes begin to stream. So loud, silent cry for sound, unreleased, take it to. Does this make it new, where the circuits breathe? T-shirt song, waiting on the counter there. Dozzy's hands will make it strong, revive the rhythms lost in air. So clear, so clear, his touch will bring the music back.
So, as you can hear, there's a lot of hum and nastiness in that recording, and that's basically because none of this was screened. My light-proof container involved me switching the workshop lights off and putting a cardboard box over this thing. But yeah, no, it does work. It's very in your face. I think the compression's quite extreme, but you could tame that by altering some of the circuit parameters. I'm not going to go into that here because I'm not going to use this. I just proved it was a valid concept. Certainly, by the way, if you built a PCB for this, it would be a lot quieter. The only big problem with it really is it will always be noisier than the software sort of version, because as this gain is so high on this output amplifier, when the LED is unlit and the LDR is dark, it's going to amplify all the hiss and noise that we've introduced in the filters, and that just doesn't happen in the software. You know, we're just dealing with numbers. The only noise we've ever managed to introduce in there really is in the analog to digital converter on the input. So yeah, this cheap, cheerful, 6 op amps. I used a TLO84 in there and a TLO82 because I've got boxes of them. But yeah, it does function. So I have made a PCB for this, so if you want to actually make one, I've put the Gerbers on my website along with a write-up of this whole project, by the way. First time I've written on the website, I think in a couple of years, so there you go. Anyway, all the details are there, so you could have a go at that. If you do, let me know how you get on, or maybe some improvements to it. So a couple of weeks ago, I believe, in a video, I mentioned that I was having a battle with an eBay seller, and that has really delayed this project, and it was all over this case. I'd ordered a case to put our project in, and yeah, I'd been quite badly let down. 3 to 5 days delivery, they said. Took 3 weeks, and it wasn't the delivery company's problem. It was the fact that the guy hadn't dispatched it. 3 weeks. Various messages telling me to check the couriers, etc., when I hadn't got a tracking number, so he was just full of it. Anyway, I have removed the screws. As you can see, it's quite a substantial steel case. I was hoping that this front panel was going to be a plastic panel or maybe removable, and whilst it is sort of removable, it's a folded steel piece, and that's a bit of a pity because my metalworking skills are famously awful, and I do want to put some bits and pieces on the front. I want a power LED, for example, and I also want to include a VU meter. So I've got this Russian VU meter that I bought from eBay from a guy in the Ukraine. This PCB here isn't really designed, it's part of another, quite frankly, failed project, and it wasn't really designed to drive a VU meter. In fact, it probably would have been better driving our compressor LED than it is driving a meter. There are a few modifications, a few bits missing, etc. So yeah, find another VU meter circuit, because this isn't very good. But it'll do for this for now. So yeah. So I'm in two minds as to what to do here. Clearly, we need to install our transmitter, which I think I'm going to sort of mount in like that, and our teensy frequency filters, compressor and frequency generator, and hook that all up. Now, obviously, if you're going to make an analog filter compressor, use the other nano style of frequency synthesizer. You can cut that off. That'll go in there. Work very well. But yeah, that's what I'm going with. So there we are. So yeah, that's what's going to happen there. I want to take this weird pot out of this transmitter here and fit one to the front panel so I can adjust the level. I want an on-off switch. I want my VU meter. I want an LED to show the thing's going, and that's about it really. But I am in two minds to whether to attempt some metal work or take this whole piece out and maybe 3D print a new front. In two minds. I have to say, I do like the idea of it being metal, but am I capable of making a decent job of it? I guess there's only one way to find out.
1 week later.
Right, back on the transmitter project. Unfortunately, I got ill, so there's been a little bit of a gap. Anyway, here's our metal front panel. I have disassembled it from its discussion, and yeah, as I think I mentioned last time, my metalwork skills are legendarily awful. So I bottled out and I 3D printed that. I'm quite pleased with how that looks. It's going to look rather smart in there. So yeah, I'll just take you through. We've got a level meter there. This is going to be my power switch. That's going to be my input drive control. I'm going to take that pot off the transmitter. I've got one on the front there, and this I'm going to use to bypass the compressor, so we can have output from the compressor or just output from the input. Does that make sense? Yeah, so just bypasses the compressor. Right, so now unfortunately I do have to do some metal bashing. I have marked out on the back here, I've got two connectors there. These are going to be these binding posts. I'm going to have one for antenna and one for earth. You know, you could put a good buddy socket on there or a BNC or something, but this is only going to have a feed a length of wire. So yeah, I'm not going to go mad. Yeah, one for antenna, one for earth, one for audio inputs. Sorry, one for power. We've got a little barrel jack there. Just an ordinary RCA socket there for audio coming in. So yeah, I've got to drill things. Wish me luck. One other thing I've also marked out, hopefully in the right place, mounting holes for the various PCBs. So put some little standoffs in there, and hopefully with any luck that might just line up. It won't line up, I'll tell you now. So there we are. I'll just eyeball it, I think. Looks reasonable at the moment. Don't suppose it will by the time I've finished. And now you know why I shouldn't be left alone with power tools. Right, I'm 3D printing some spacers to go under here. So while that's happening, I'm going to fit the back panel sockets. Now, the one that's going to the antenna, I have previously printed some bushings just to keep the connection from being shorted back against the case. So that sort of fits like that. You can see in there, there's a gap that stops it from shorting out against the case and grounding what precious little RF we've got. I want a washer in there. Just take one off there. I'm just going to put a tag on there. Ideally I want another washer. That's it, bolt that lot up. Find a suitable nut spinner just to do that up. Somebody asked me the other day where I got these from. These are 3D printed. They're actually for repairing guitar front panels, but they're great. They're completely see-through, so if you've got a long pot shaft or something, you can still get on the nut. Come in all manner of different sizes, and they're really useful. And because they're 3D printed, if one gets chewed up, I'm not worried about it. Right, this bottom antenna connector here doesn't have any spacers on it because I want it to actually go back to earth. But what I do want to do is just scratch some of this paint off, so I've got some sort of earth continuity there. Yeah, that's pretty good. I've got a spring washer there to bite into it. I think I will add a tag on there. Going to want another washer, aren't I? There we go. Audio jack. And the power jack. Yeah, don't think that looks too shabby. Right, sounds like my 3D printed spacers have finished, so I'm going to go and get those. I want some M3 screws. And I'm getting a bit low on these, going to have to invest in some more. There we go, that's 8 of those. What I'm just going to do, stick them through on here and then dob them down with a bit of blue tack so we can get the boards lined up. Well, I have to say, they didn't leave us enough room between the end of that screw and that capacitor to use that particular bolt hole, so I'm just going to sack it off, I'm afraid. Never mind. Now you see, I haven't quite thought this through, have I? Because I haven't removed that pot from the board yet. So I'm going to have to take all that back off again. Oh. Anyway, I think the Teensy board is in rude health to go on there, so let's try and fit that. Right, take this one back off then. Okay, now we're starting to get there. I think that's our transmitter sort of sorted really, although I suppose I could do with connecting some wires up to the back of the power jack so I don't have to bother with a power jack. So yeah, let me just do that quickly. Right, let's just make sure I got that round the right way, because I'm not convinced I have. Multimeter to continuity. Right, let's just lop this off here. I think I have got it the wrong way around as well. Okay. Should have looked at the schematic, shouldn't I, really? It's pretty well documented. Right, that's got that out of the way. So the next thing to do, I think, is to wire up my front panel. I'll push that LED in a little bit more. There we go. So first thing I want to deal with is the power switch, I think, really. So I'm just going to get myself a little bit of my red wire here. Okay, that one's coming in, and now then it goes out, and it goes out to two places. It goes out to the transmitter board and to the teensy board. So yeah, let's make that happen. So I get a reasonable length here, and I'm just going to put that to 2 and then cheat a little bit by just stripping the centre out of it a bit. That way it'll make it easier to solder with a bit of luck. There we go. So I've just got a little bit of exposed in the middle without cutting it. Fold that back over, tin it up. I'm just going to solder that onto the centre pin of this switch here. Okay, that's my power. The audio is a little bit more complicated because that has to go two ways as well. I need the audio to come from the socket into the compressor and also into the switch, so that when I bypass it, we've got somewhere to bypass it to. So I think I'm going to employ a little bit of screen lead to come from the audio socket. Do I want one piece or do I want two pieces to go to two separate locations? It might be just as easy to go with two pieces. I'm therefore going to use a stereo pair. So that should be more than enough. And I think I'm going to attach it onto the socket first and then work my way to the front panel. So yeah, that should be enough. Okay, so one of those needs to go to the front panel and the other one needs to go to the teensy input on the right hand channel. Okay, that's that. Then that goes to one side of the switch. I'll come back to that in a bit. Power we've got sort of sorted when we come round to that. I'll have to join that one up, but that's all good. So let's leave that back there for a second. Oh, we need output from the compressor back to the switch. Let's put that in. Right. Steadily we shall get there. So those two leads are going to come top and bottom here. That middle lead is then going to feed our pot. So let's implement that next. Let's see if we can find a different colour of wire. I choose this yellow one. Let me think about which way round this has got to be. So that's fully quiet, that's fully driven. So that needs to be that pin there to the centre of the switch. Lovely. I'm just going to disconnect this meter from here for a minute. Get rid of that board. There we go, it's better. Okay, so the centre output goes to the transmitter and the end goes to ground. Another little bit of screened cable here. One thing I'm going to do before we go any further, let's just shield this pot slightly by soldering one end of this can up, if I can. Might need to change my soldering iron bit. It might be some form of plated steel and won't take solder. They're normally okay. So let's have a go at it. Yes, it is. Hurrah! Okay. So what I'm just going to do is I'm going to attach a wire between that pin and there, just to shield the pot. Might cause a bit less hum, maybe. Right, solder this bit of screened on. That's it. So those two audios come in there and there. Solder splash on the back of my VU meter. Disappointing. Get that off in a minute. LED is driven from a current limiting resistance here. So that can just plug in. That's power input. That goes out to drive the VU board. I think the way I'm just going to mount this is to bodge that with a bit of hot melt onto the front panel, wire that back up, and of course this actually has to go to the output of the pot as well. Right, let's do that. Excellent. Right, I'm going to have a cup of tea.
Many unbearable hours later.
Well, I had my cup of tea, and I came back and I started wiring things up, and I thought, I'm not going to film it, it's just me wiring stuff up. I've assembled the front panel, rather pleased with that. It's got a sort of 80s CB vibe, I don't know, but yeah, I'm quite pleased with that. And finished all the wiring up, switched it on, and got nothing. So I started diagnosing things, and it turns out that the frequency generator wasn't generating a frequency. And I investigated into it, and after a lot of messing around, it turns out there was a fault in the code, because it would work fine when it was running from the USB, but not when it was running from our own internal 5-volt regulator here. And I took it back apart, make sure the link was cut, upload the code, it would run fine. Once, and once only. Turns out there was a bug in the code, whereby, yeah, I'm still not really quite sure, but pins weren't being defined. So the frequency generator was just set to off all the time. So I thought I could have found that. Put all that back together. Switched the transmitter on. Absolutely nothing at all. I've got frequency coming in on our two little links there that feed our drive transistor. So I thought, well, why aren't we getting anything? And we're having a probe around and there's no DC anywhere. So that's a bit unusual. And it turns out the pot I removed, this one here, it's got a switch on here. And of course, having removed it, the switch was off. So I put a little short link in there. The two pads are there and there, where the pot was, there and there. But you can see this comes across on quite a fat via into tube things there. and then over there. So I just dropped a wire link in there, and we've now got power. Unfortunately, R33, which is that small resistor there, lit up, and yeah, is no longer a resistor. And there was no blue LED or anything. So that was a fail. So I've just had a look at what R33 did. I've fitted a new one now. So, in fact, it's R1, 33 ohms. It's quite confusing the way this board is laid out. But it takes our 9-volt supply, I'm giving it 12, well, I hope for the best. And it's just a little current limiting resistor here into the power supply of this audio amp, which is that SIL device there. And yeah, I don't know why that lit up, because I've powered this up separately now, granted with no frequency source, but the resistor doesn't light up anymore, so I'm not quite sure what's going on. But yeah, it's getting quite late. I've had enough. It is, in fact, 10 to 12, 10 to midnight. Yeah, I've had enough. I'll see you tomorrow.
The very next evening.
So it's just gone 8 o'clock the following evening, and I've sorted it. It was a wiring error in our transmitter board. I think I got the polarity of the power supply the wrong way round. Thankfully, the only thing I did damage was that 33 ohm resistor, so that's been replaced. The other thing I had to do is add a pot in here on the audio input just to turn it down a shade. Not really a fault of the transmitter or the compressor or anything like that. It was a fault really with that VU meter circuit. I mentioned earlier it's rubbish, and it just wasn't sensitive enough. So I've turned the gain up there, turned it back down there. Not ideal, but at least I'm getting a sensible indication on the front. I did also mention that you could run this thing on 12 volts to get a little bit more out of it. If you do that, two things happen. The modulator transistor still runs a little bit too warm for comfort, and also you start to get some horrible asymmetrical modulation occurring. And while it sounds all right, I'd hate to think what it's doing to the spectral purity of the RF coming out. Yeah, not good. So I've backed that back down to 9 volts, and to that end I've added one of those little eBay boost converters, sorry, buck converters on the back panel set to 9 volts. It's an LM2596 for reference. I'm quite pleased with how it looks from the front. Compressor in is down, power is there, and yeah, very pleased. Just as an aerial, by the way, I'm using about 6 foot of wire which disappears up onto a shelf across the back. While we're on the subject of power supplies, I will mention, if you do get a load of noise and rubbish from a wall wart, it's probably because it's a switched mode one. Best to get a linear one if you can. And you don't even need to regulate it, as long as it's got enough headroom to produce 9 volts at the output of the buck converter there. It'll be fine. It's just that if we start referencing things to earth, we start inducing all manner of hum. And in fact, if I plug the MP3 player I'm using into the charger, it sounds horrible. So yeah, another way to combat that would be to add an audio isolation transformer either in the lead or yeah, inside itself. You can get those. I've used them previously on projects. You can get them on eBay. They're called line isolators for car hi-fi to remove ground loops. You could add one of there new if you wish, but just for now this suits me fine. So I'm going to button it up, and I'll let you listen to it on the way out. Thanks for watching. Click like, subscribe, do all that rubbish, and I'll see you really soon here on Doz's Television Workshop. Cheers now, bye.
unfold. Stories told as the night grows old. Voices echo in the ether clear, casting spells for all who hear. Frequencies that light up the night, guided by passion, taking flight. Nothing saying we'll find the wrong. In its melody we find out. Tuning off the signal call as the airwaves take us where we want to go. In the static sequence intertwined, every summer journey, one of a kind. Crosses air, beacon in the air, through restless nights and dreams we share. From distant valleys to urban sprawl, the station's call connects us all.
Tuning in to Doz's wondrous sounds. Ruin waves, they rolled around. Lost in rhythm, time unwound. Feel the beat, it's profound. Doz's AM, take my hand. Ride the waves across the land. Songs of future, sky so grand. In this sound will forever stand. Through the static dreams unfold. Stories told as the night grows old. Voices echo in the ether clear, casting spells for